All right, so continuing lesson 5.1, relations and functions. All right, going on to number 7, right? Well, first off, there's you a definition, okay? And this is the most important definition basically of not only this activity, but also kind of this whole concept that we are learning. A function is a relation, right? We know a relation is something that can be put into ordered pairs. A relation in which each input is paired with exactly one output. You're going to get well familiar with this term and the definition of a function, because anytime they ask you to explain, right? Like for instance, number 11. Number 11 is going to ask you if it is a function, okay? And explain your answer. Well, you explain your answer by giving the definition of a function, okay? That's how you explain your answer. All right. So a function is a relation in which each input is paired with exactly one output. So let's take a look at number 7. Number 7 says compare and contrast the DVD vending machine with a function. So basically, compare and contrast, right? Is the DVD vending machine, is it a function? Think about it for about 5 seconds and then raise your hand.
No.
All right, then raise your hand. Anybody? What do you think, Bryce?
No.
Why?
Because not every input has an output.
Okay. Anybody else? Anybody else? He said that not every input has an output. So he says no. Anybody else? What does the definition say again? A relation in which each input is paired with exactly one output. Okay? If I push A1, I get Hunger Sports. Do I get anything else? If I push A2, what do I get? Revengers. Do I get anything else? If I push A3, do I get anything else? If I push B1, what happens? Nothing. Do I get anything else? No. I don't get that it's sold out and the Revengers pop out, right? Same thing. B2, I get B3, Insect Man. C1, I get only the Dependables. C2, I get only the Light Knight. C3, I get only the Light Knight. So is every input paired with exactly one output? Yeah. All right. Every input is paired with exactly one output. It resembles a function because each input, which is the button pressed, has at most one output, which is a DVD. Again, suppose when pressing the button C1 of the vending machine, both the Dependables and the Light Knight come out. Describe how this vending machine resembles or does not resemble a function. Think about it for 5 seconds, then raise your hand. We're doing number 8. Think about it for 5 seconds, and then raise your hand. Somebody that hasn't talked in a while. Ken, what you think?
It doesn't, because it's two different outputs.
And what's the definition of a function?
One input has exactly one output.
There you go. So does the vending machine represent a function?
Nope.
No, because each input has more than one output, so it's not a function. Right? Yeah. So It would not resemble a function because each input, C1, yields two outputs. And a function cannot have an input without more than one corresponding output. Number 9, imagine a machine where you can input your age and the machine gives you the name of everyone who's that age. Compare and contrast the machine. Okay? All right? So compare and contrast the machine. Okay? So let's do this, okay? Let's say that in this class, right? In this class, we have 13-year-olds, 14-year-olds, 15-year-olds, 12-year-olds, 16-year-olds, 17-year-olds, 18-year-olds, 15. Okay. You gave me this and I didn't know. I'm like, 12-year-olds? I'm like, this is high school. I don't think we should have 12-year-olds. All right, but it's okay. I mean, it's plausible to have a 13-year-old, but generally it's 14, 15, 16. You may even be 17, right? Algebra 1 may be a class that you needed to catch back up on. It's plausible. I taught a kid last year that for whatever reason his Algebra 1 credit did not transfer from California, and so he had to take it again to graduate here in Louisiana. All right? And he was a senior in high school. Right? It wasn't his fault. It wasn't like he failed it or anything like that. It just is what it is. Right? So anyway, so let's say this. So we got some 13-year-olds, some 14-year-olds, and some 15-year-olds. Now I'm going to put this on the internet, so I'm going to kind of be mindful of that. So what I want you to do is let's create a, here I'm going to click out of this, and hopefully this still stays with the recording. Actually, I'll just write it here on like this. So we have, let's say that we have some, give me a little room here. Let's say that we have some 13-year-olds, some 14-year-olds, and some 15-year-olds. Okay? And let's say we have, let's see, we have, give me some names. Larry. We have Larry. We have Sarah with an H or without an H? Doesn't matter. I'm going to go with an H because my grandmother's name was Sarah and had an H. And yesterday was 6 years ago that she passed. So, Carl with a K or with a C? All right, let's see. So with a C. So Dr. Carpenter would be upset about that. All right. Let's see. Huh? Joe? Mo? Pop Smoke? What? Okay.
No baby.
All right. Little Baby. All right. So Little Baby, we're going to make him 13. All right. Little Baby, if you ever see my YouTube channel and I labeled you 13, my apologies. All right. So how old is Larry? 15. How old is Sarah? How old is Carl? 15. How old is Joe? 13. How old is Mo? I heard 13 first. How old is Pop Smoke? 14? 15? And how old is Little Baby? 14. Because we only have one coming off that is Little Baby is 14. All right? So take a look here, right? And you're like, oh man, Mr. Lemons, this is kind of confusing. But you can follow the arrows and you can go through now. Is this a function? Why? What has more than one output? The ages have more than one output, right? 13. So if I would say this, like right now in class, all right, All the 14-year-olds stand up. They can't, there's not a video, so they can't see. All the 14-year-olds stand up. Did I have only one stand up? No, I don't, right? I had 1, 2, 3. I can't count, but let's say that's 9, right? I had 9. Actually, I think that'd be 10 of y'all. I had 10 of y'all stand up, right? So that's not a function. Okay? Y'all have a seat. All right? So because it goes, right? Because it goes off and everything, no, this is not a function, okay? And here's just another little better example or graph kind of what we did. But hopefully you wrote down, because see, this has Zach and Tina. It don't have Pop Smoke and Little Baby and, and Joe and Mo and Sarah and all those other cool names like we did, right? I don't know about Larry, but anyway. All right. So now number 10 wants us to, and again, the answer for that is that no, it will not be a function, because each input can be paired with multiple outputs because there are multiple peoples who are the same age. Okay, so all you do is draw a mapping of ages and names and show the multiple ages go into different names. Create an example, a situation, math or real life, that behaves like a function, and another that does not behave like a function. Explain why you chose each example to fit the category. All right, what is something that behaves like a function? What did y'all come up with? Anybody? The example here says each item in the store has one price assigned to it. All right. That would be a function, because the price of a 20-ounce bottle of Coke is not the same as the price of a 20-ounce steak. Because if it was, I'd be buying steaks every time instead of a Coke, right? And the example it gives for not a function, right, is it gives a set of ordered pairs, 2, 3, 2, 5, 3, 1. And the reason behind it is that the input 2, right, I have an input 2, and the input 2 is used twice. It gives 2 outputs, 3 and 5. So then it's not a function. Anybody have one that is a function? You could have a movie ticket and the certain name of the movie, right? If you get a movie ticket for James Bond, can you go see Venom? No, right? Well, you're not supposed to, right? All right. But some of y'all get movie tickets and y'all go watch about 4 or 5 movies. All right. Ella, Mackenzie, guilty. Look at that face. She's like, I've done it. Okay. So anyway, you got one, Elias? Yeah. What? Okay. Bryce?
Like, you have an iPhone, you can't put 2 accounts on it. You can only put yours.
Yeah, your iCloud account, right? You only can put, so your phone, your phone and your iCloud account or whatever, because you can't have multiple iClouds account on there at the same time. I don't know if that's true. We're gonna table that. I like where your thinking is, because to you that answer is correct. I just don't know if it's actually correct, but your understanding is right. Okay. Let's say that textbooks, right? Every person has their own textbook. Okay. If I sit there and I have Kaysen's textbook that has her name on it, right? This textbook goes to her, right? This textbook doesn't go to her and Kale, right? It doesn't go to both of them. It only goes to her. Okay. Now, what's something that would not be a function? Yeah.
Like your Xbox, how you can have like two Xbox accounts going.
Okay. Let's do color of socks, right? How many people are wearing white socks right now? All right, I got right out of the gate, I got more than two. White socks, more than two. Not a function. Okay. How many people are wearing a hoodie? People wearing a hoodie. More one hoodie, right? A hood, you get what I'm trying to say. And so it's like, hey, that's more than one, right? It's stuff like that. Like just exactly how we saw with the ages and things like that. We have the age and we have multiple people. If it's one input going to multiple things, it is not a function. It's like what we talked about with the juicer, right? Apples give you apple juice. If it gives you apple juice and grape juice, something's wrong. It's not a function. Okay? So let's take a look at 11. I'm going to go up here and I'm going to turn the answers off. Let's take a look at 11 and let's talk through these. And let's see if you think these are a function or not. So determine the ordered pair and equations represent functions. Explain your answers. All right, explain your answers. So let's take a look at A. Is A a function? Why do you say yes? And I need class participation in this, please. Yeah, so I have a 5, right? 5 gives me only 4, right? 6 gives me only 3, and 7 gives me only 2, right? One input, one output. So the answer to this is yes, it is a function, right? And how do you explain your answer? One input has exactly one output, right? You're going to take this definition here that I highlighted, right? This definition here that I highlighted, and you're going to say this right here. Each input is paired with exactly one output. That's going to be your explanation. So you're going to have to write that. If we say yes, you're going to need to write each input is paired with exactly one output. All right, let's go back to B. So we have 4 goes to 5. We have, 4 goes to 3. And then we have 5 goes to 2. Is this a function?
No.
Why?
Because 4 went to 5.
Because the input 4 goes to more than one output. I'm still using the definition, right? But I'm using, I think the term is the conjugate of it. It's the negative, right? Is that you are taking the 4, right? And so you're going to say, no. The answer for this one is no, because the input 4 has more than one output. All right, the input 4 has more than one output, right? So if you are looking at these and you get a set of ordered pairs and it wants to know if it is a function, right? And it wants to know if it is a function. If you look and you see that the x values, right? You're looking at the x values and you see the same number repeat, that should automatically be a no. Okay? Unless, of course, they are trying to trick you and they have another one over here like this, right? Let's say that this one didn't exist and you had 4 or 5. Would that be a function? Yeah, because you wouldn't have this, right? You would just have 4 going to 5 again. Okay? That's still one input, same output. That's like having, if you push a button and it gives you a Coke, right, from the vending machine, it doesn't matter if it gives it to you from the top shelf or the bottom shelf, it still gives you a Coke. right? All right, so take a look. Look at C. Without drawing the mapping, take a look at C. Is it a function? I have 5, 6, 7. Does any of my inputs repeat? No. So yes, the answer is yes.
So it doesn't count if like.
Oh, it doesn't matter. Look, I have 5, 6, and 7. It doesn't matter with this, right? I got 5 going to 4. I got 6 going to 4. And I got 7 going to 4. That 5 has how many arrows? 1. That 6 has how many arrows? 1. That 7 has how many arrows? Look up here. This one's not a function because the 4 has how many arrows? 2, right? One input gives me one output. Doesn't matter if it's the same one. If I have 4 quarters, that's still going to be what? $1. Is a 4 quarters the same as a dollar bill? No. One's rectangular and paper. The other is 4 metal cylinders. Physically, it's not the same. But is it the same? Does it still give me the same output? Yeah, it's still $1. Right? 100 pennies is 100 pennies. That's not the same as having $1 bill, but it's worth $1. All right, look at the, all right, so I have an equation, right? I have an equation, and let's say I have some values of x and some values of y. Let's say I have a 0. So y equals 3 times 0 minus 5. 3 times 0 is 0, so that would be y is negative 5. Let's say y equals 3 times 1 minus 5. What would that be? Negative 2. Let's say y equals 3 times 6 minus 5. What would that be? That'd be 6 minus 5, which is 1. We see there's a common difference, right? There's a rate of change. This is increasing. This is going every time that this increases by 3, right? This is increasing by a 3. So every time this increases by 1, that increases by 3. So it's going to stay that way. So will any input ever have more than one output? No. So is this a function? Yeah. What do we write when we have a function? Every input gives me exactly one output. What about this one? Do you see anything different other than the x just being negative now? Because look, if x is 5, that's now going to say y is now going to be what? Negative 5 plus 4, that's negative 1. Well, what about if x is negative 5? Well, that's going to be 9. So this is still a function. That is still a function. When you have an equation, the only time you're going to get one that's not a function is if there's an exponent involved. Okay? For instance, you have y equals x squared. Like plus 4. You'll start getting stuff like, well, let's see, no, that still wouldn't. No, I'm trying to think. With equations, when will you start getting? Oh man, I haven't thought about that in a while. So I'll have to get back with you on that one. But anyway, I didn't mean to push that. Sorry. But yes, this one is a function. Okay. You'll see, like with equations, you'll clearly see that, hey, if it is a function, if it's not a function, right? We'll clearly start seeing that. So here we go. Let's go to number 12, right? Using positive integers, write two relations as listed order pairs below, one that is a function, one that is not a function. We said before, in order for it to be a function, the x values have to be what?
The same.
Not the same. Okay? So you could have said, 1, 2, parentheses 2, 3, parentheses 3, 4, right? As long as they are not the same. For not a function, you have to have an x value that repeats. Okay? For not a function, you have to have an x value that repeats. You have to have an x value that repeats. Okay? So we now have numbers 13 and 14. We now have numbers 13 and 14 on page 69. I need you to work those for me, okay? I'll give you about 2 minutes, and then we'll go over the answers. All right, let's look. So number 13, does the mapping show and represent a function? Explain your answer. Yes, because every input is matched with exactly one output, right? There's only one arrow. Number 14, does the graph represent a function? No, because the input value 2 has more than one output. And this is page 68, 69, 7 through 14.